let's look at solving nonlinear inequalities. So guidelines for solving nonlinear inequalities. First, we're going to move all terms to one side. If necessary, rewrite the inequality so that all non-zero terms appear on one side of the inequality sign. If the non-zero side of the inequality involves quotients, bring them to a common denominator. Second, we'll factor the non-zero side of the inequality. Third, find the intervals. Determine the values for which each factor is 0. These numbers will divide the real number line into intervals. List the intervals that are determined by these numbers. Make a table or diagram. Use test values to make a table or diagram of the signs of each factor on each interval. In the last row of the table, determine the sign of the product or quotient of these factors. And finally, solve. Use the sign table to find the intervals on which the inequality is satisfied. Check whether the endpoints of these intervals satisfy the inequality. This may happen if the inequality involves a less than or equal to or greater than or equal to. So let's take a look at our first problem. And I think it'll make more sense when you see the steps in action. So let's solve the inequality x squared is less than 5x minus 6. First of all, let's get everything to one side. So we're going to subtract 5x and add 6 to the left-hand side and the right-hand side. And actually, you know what? I'm going to rewrite the question. All right, so we're going to subtract 5x and add 6. Subtract 5x and add 6. There we go. All right, so now we have x squared minus 5x plus 6 is less than or equal to 0. All right, so nothing would change our inequality sign. We've just moved some terms to the other side. So now we can factor. All right, so you can use factor by grouping, or maybe you recognize the factor. Just in case, I'll do factor by grouping. All right, so 1 times 6 is 6. Two numbers that multiply to give us 6, but add to give us the b term of negative 5. It's going to be negative 2 and negative 3. So that'll be x squared minus 2x plus negative 3x plus 6, or less than or equal to 0. First two are a group, second two are a group. We can factor out an x. We're left with x minus 2. We can factor out a negative 3. We're left with x minus 2. And then we can factor out that common factor of x minus 2, and then we have the leftovers x minus 3. All right, so we have just solving the quadratic, there's two equations. So x minus 2 equals 0, x is 2, x minus 3 is 0, x is 3. All right, and so that's going to be the boundaries of our intervals. So we're going to look between negative infinity and 2. And 2 and 3, and 3 and infinity. All right, so let's look at the first one. All right, so I'll change colors here. So here's my table. It's not going to be too fancy. All right, so we have negative infinity to 2. We have 2 to 3. And 3 to infinity, and that's the values that we want to check. Actually, you know what? I'm going to write them horizontally. I think that would look nicer. And I won't put anything between them. Let's just do that. All right, so those are the intervals that we want to check. All right, and so, and we're going to check x equals 2 and x equals 3, or x minus 2, and x minus 3. Oops. Okay, we'll try to keep that out of the, there. So x minus 2 and x minus 3. All right, and we'll check the sign values, each of the factors, the values for each of the factors. So for each interval, we'll check that particular factor to see, all right, in that interval, if I plug into that interval, am I going to be positive? Am I going to be negative? And then we're going to have x minus 2 times x minus 3. I need more space. Or I need to write smaller. Right, so all we're doing here is checking the signs. I have lots of space here at the bottom for each of the intervals. All right, so let's look at values for negative infinity up to 2 in the factor x minus 2. So if I plug in 2, right, we'd get 0. But what if we plugged in values that were less than 2, right? So we're not including 2. Plugging in values less than 2, like 1 or 0 or a negative number. Right? And all of those values we're going to get in negative. Right? So for the interval from negative infinity to 2, anything I plug into x minus 2 is going to be negative. What if I plug in values between 2 and 3? All right, so we plug in 2.5, right? Well, that would give us a positive 1/2. So anything in this interval is going to be positive. What if I plug in numbers greater than 3? All right, so 3 minus 2, that's 1, that's positive. 4 minus 2, 5 minus 2. Matter of fact, anything greater than 2, when I start plugging numbers in, I'm going to get a positive value. All right, so we've checked the signs for x minus 2. It's negative for negative infinity to 2. It's positive between 2 and 3. And it's positive between 3 and infinity. So what we want are these we want to check these intervals in each of the factors. The only reason I solved for 2 and 3 was just to give us the boundaries. All right, so now let's do the same thing but check with x minus 3. All right, so if I plug in something less than 3, like if I plug in 2, 2 minus 3, right, that's negative 1, 1 minus 3, oh, that's negative 2, 0 minus 3, that's negative 3. So anything in this interval is going to be negative. What if I plug in values between 2 and 3? All right, so if I plug in 2 minus 3, that's going to be negative. Matter of fact, everything except for 3, which would be 0, is going to be negative. And if I plug in values greater than 3, then it's going to be positive. All right, so now we're going to check the product. All right, so the first one, x minus 2 is negative, x minus 3 is negative. All right, well, if I take a negative times a negative, and I'll put that right there, negative, that's where I'm coming with this. Negative times a negative, that is going to be positive. If we take a positive times a negative, that's going to be negative. And if we dot different multiplication. If we take a positive times a positive, that's going to be positive. So we want, let's check what our inequality said, and that we need to go back to this one where everything is on one side. We want values that are less than 0. Well, the only place where we get a product that is less than 0 is going to be on the interval 2, 3. So that's going to be our solution set here, is the interval of 2 to 3. So we want x such that x is between, it is greater than 2, but less than 3. Oh, and excuse me, this was an and. This was a less than or equal to. So let's see if our endpoints, let's double check our endpoints work or not. So if I plug in 2, I'm going to get, well, we're going to get 0. So, and 0 would be equal to. Yeah, so we will include the 2 and the 3 because we're going to get zeros, right, when x is 2. Right, because 2 minus 2, that would be 0. And 3 minus 3, that would be 0. So right at 2 and 3, they're going to be 0. And that's okay, right, because we're less than or equal to. We wouldn't have included 2 and 3 if that was just less than instead of less than or equal to. So that's our interval. So now let's graph. Sorry, I couldn't reach my line tool. And let's try to get arrows on both ends. All right, so there's our number line. All right, so 0, 1, 2, 3, 4, 5, 6, there we go. All right, so we will include 2 and 3. So we'll have a closed dot, right? These are both closed dots. And it's just want everything in between 2 and 3, including 2 and 3. All right, and there we go. All right, so for these ones, we're going to, here's our fact, so we got everything on one side, right? We set it equal to 0. Actually, let me write a different color so it stands out. Or I didn't really write in black, so set equal to 0. Then we factored. Oops. I hate when it gets stuck. Not even going the same direction. All right, so then we factored. And then we created our sign chart. All right, and so here were our test intervals. And these were the values being tested. And then here's our product. And so that's going to determine our solution. Right? And then we wrote down our solution, and then we graphed our solution. Right? And that's all of the parts to this. So it's a little more complicated than linear inequalities, where we just have to solve, and that's it. Here we have to check because we've got different factors. Let's do one more. All right, or maybe two, but let's do this one. All right, so this one's already factored for us. Solve the inequality x times x minus 1 squared times x minus 3 is less than 0. All right, so here we have, several. We got repeated factors, so we have several factors to check, but we've already got it solved. So our boundaries, so if we have x times x minus 1 squared times x minus 3 is less than 0. I should say not equal to. All right, so we're already isolated. So we have solutions here at x equals 0, x equals 1, and x equals 3. That means the intervals that we're the values that we're testing are the values between negative infinity and 0, 0 and 1, 1 and 3, and 3 and infinity. All right, so we're going to check values in each of those intervals. All right? And let's do it underneath. I think I have enough room underneath. All right, so here's our values being tested. All right, so negative infinity to 0, 0 to 1. Oops, I don't need that there. 1 to 3, and 3 to infinity. And we're checking it in x minus 1, x minus 3, and then the whole product of x times x minus 1 squared. Oh, actually, I'm sorry. That'll make a difference. So that's not really x minus 1, it's x minus 1 squared. And so we have x times x minus 1 squared times x minus 3. And then we'll check it out in the product. All right, so if I plug in, and this time we don't want the endpoint, so we don't want zeros, because this is just a less than, not a less than or equal to. All right, so if we plug in a negative number for x, all right, that's going to be negative. Right? If I plug in a negative, it's going to be negative. If I plug in a negative number for x on the second one, x minus 1 squared, no matter what I plug in, I'm going to get something positive, right? Because we're squaring. So that's always going to be a positive number. If I plug in something negative, less than 0, and I subtract 3, I'm getting more negative, so that's going to be a negative value. Right? So like, for instance, if I were to plug in negative 2, right, that's less than 0. Negative 2 minus 3, that's going to be negative 5. That's negative. All right, so negative times a positive times a negative is going to be positive. Right? So that's going to be a positive product. How about the next one? All right, so if I plug in something between 0 and 1, well, those are positive values, so that means x will be positive. X minus 1 squared is always positive. So there we go. All right, if I plug in something that's between 0 and 1 in for x minus 3, I'm going to have something negative, right? Because that's less than 3. So if I take something that's less than 3 and subtract 3 from it, it's going to be a negative number. I'm multiplying two positives and a negative. That's going to be a negative. An odd number of negatives makes it negative. All right, and then the next one, we have between 1 and 3. Right? Well, those are positive numbers, so that'll be positive. This one was always positive. All right, and if I plug in 2, 2 minus 3, that's negative. So this is still negative. All right, so now if again, this is positive, so x is going to be positive. And this is always positive because it's squared. All right, so but now if I plug in something greater than 3, this will be positive as well. So the product here is going to be a positive value. All right, we want it to be less than 0, negative. So we're negative on the interval 0 to 1 and 1 to 3. All right. If we were solving for x greater than, if instead of saying less than, this said greater than, then our answers would be negative infinity to 0 and 3 to infinity. Because it says less than, it's going to be between 0 and 1 and 1 and 3. Right? And you might think, why can't we just call that 0 to 3? Right? We can't include 1. Because if I plug 1 in, this one right here would be 0. And we don't want equal to 0. We want less than 0. All right? And if one of them is 0, if the whole product is 0. So we can't include 1. So our solution set is going to be x such that x is between 0 and 1. Oops, I forgot my sign there. Or, let me make that looks like a 4 now. Not a less than 1. Or x is between 1 and 3. Right, so we can't use this, we can't be equal to 0. So that takes the 1 out. Everything else is fine. To graph it, no, I got only one arrow, so I'll draw the other. All right, so I'll just start -1, 0, 1, 2, 3, 4, 5. Okay, so we have an open circle at 0, because that value is not included. We have an open value at 1, because that's not included, and an open value at 3, right? Because these are all less than symbols, right? No equals 2. All right, so we're essentially not including the endpoints, and we're skipping over the value 0. So we're just sandwiched in between those values with an open value at 0, 1, and 3. All right, and that's all there is to these. All right, so they're a little tricky, all right, but once you get the hang of it, it's kind of, you know, like solving a mystery. Which interval is it? All right, so thanks for watching, and bye for now.